Because, well, the normal tendency for scientists is to look around them, look in their country and their surrounding oceans and so on. But if we want to have an idea, an accurate idea of why CO2 is increasing in the atmosphere from year to year the way it does increase, then we need to have information of all the countries together. And in order to do that is very difficult because the financial support is always by country or by region in Europe, for instance. But the global view of carbon cycle doesn't really exist from each country's perspective. The data comes from all over the world. It comes from different types of measurements. For instance, emissions are based on statistics on energy consumption and statistics on the CO2 content of the different sources of energy. Then we have data that comes from deforestation. We have data that come from ocean measurement of CO2 uptake by the ocean, and also from the growth rate of CO2 in the atmosphere. So it's really all over the world, all kinds of measurements, direct measurement, indirect measurement also, and as well models or tools to interpret the data, to interpolate when there's no data across stations and so on. One very important thing is that of all the CO2 that is emitted to the atmosphere from fossil fuel emission and deforestation, only 45% remain in the atmosphere, and that's because of the presence of two very large sinks, the ocean sink and the terrestrial biosphere sink. And interestingly, this fraction is more or less the same now as it was 50 or 40 years ago when the measurement started, although we have indications at the moment that the efficiency of the sink is weakening, so a larger fraction of the emission could or maybe is already remaining in the atmosphere. The two sinks will continue to work for a long time, but the percent of the emissions that they can absorb, we think, is going to weaken at higher CO2 and in response to climate change. So we think that the percentage that the sink will absorb through time will be reduced. We don't know exactly how much, we don't know how fast, and we don't know if there are some sudden changes that could occur. The ocean absorbs about 1/4 of the emissions every year, and the ocean has a huge capacity to absorb. It's a humongous mass of water, and we think that in the long term, on scale of several centuries, the ocean will absorb about 70% of all the emissions put to the atmosphere. The problem is that it takes a long time, because it takes a long time. The CO2 comes from the atmosphere and it has to mix, it has to reach the deep ocean, and that is limited by the mixing in the ocean and the currents and so on. And so that takes several centuries. And if we wait even longer with the interactions with the sediment, the ocean could absorb 80–85% of all emissions. So the ocean has a very huge control on the atmospheric CO2 in the long term, but the fast response is just not there. This is why at the moment it's only 25% every year, although over a long time period it will be more. So the ocean will respond to changes in climate, this is for sure. Some things we don't know exactly, but we know warming will be quite important, and CO2 is more soluble in cold water than in warm water. So if we warm the ocean, then it will reduce its capacity to absorb CO2. And the very important thing that we have difficulty to identify is what the ocean circulation will do. And for instance, at the moment, in the last 50 years, winds have increased a lot in the Southern Ocean in response to both ozone, the depletion of ozone in the upper atmosphere, and global warming. And because of this, the currents have mixed more, and they're bringing up to the surface the natural carbon that is rich in CO2, and that prevents further absorption of emissions in the Southern Ocean. So that's the example of the Southern Ocean, but we think other oceans, also the North Atlantic, is behaving similar way at the moment. So in terms of the physical transport, we have evidence at the moment that this could be already responding to climate, although we don't have a global view yet. And furthermore, the ocean carbon sink is very much controlled by biological activity. So small plants, the phytoplankton, grow at the surface where there is light, and they store carbon in their mass. And as they die and they are eaten by zooplankton and fish and so on, then the particles of carbon, they aggregate and they sink to the deep ocean, and that creates a natural flux of carbon. And how these small organisms are going to respond to warming and changes in circulation and nutrient supply is very difficult to say. Now, this part, we actually have no idea how this is going to respond in the future. So if we take all the information we have at the moment, we think that the changes in climate will weaken the carbon sink by 5 to 10% in this century. But frankly, I think this is a rather low and conservative estimate that is mostly triggered by the fact that we don't know what to put in our models at the moment. We lack the information. So the terrestrial biosphere is the second important sink, and it takes up at least as much as the ocean, so 25, possibly even 30% of the emissions every year. And the reason for this is because the growth of plant is limited by CO2 on land, and as CO2 goes up, then it's like vitamins. The plants grow more and store carbon. And also forests that have been cut in the past centuries, then some of them are regrowing, and that also creates a sink. Now, as climate changes and CO2 continues to increase in the atmosphere, the fertilization effect, which is the vitamin effect, that will stop. You can only increase your growth. Eventually you become limited by water or by nutrients or by something else. So we know this sink will stop. We don't know at what level of CO2 exactly. 500, 700, 1000 is difficult to say. And at the same time, with warming, as the planet warms, there are biological processes, especially bacterial processes in the soil, that become accelerated. And it is possible that the carbon sink on land completely ceases at some point and even starts to outgas its CO2 to the atmosphere. And among the models that exist now, some models, not all of them, it's the minority, but still some models by the end of this century show an outgas of CO2 to the atmosphere. The sink is caused by the growth of the biomass itself in response to CO2 fertilization. If the fertilization stops completely, the sink stops. So that's easy to understand why it stops. Now, if you start the processes that respond to temperature, bacterial processes, what they do is they degrade the carbon that is stuck in the soil in particular. So degrading the carbon means that the carbon just comes back to the surface. For thousands of years, the earth was in balance. So how much it grows, the detritus in the soil, and how much goes back, and on a year-to-year basis, this is in balance. But if the remineralization process, this is what it's called, the bacterial degradation, becomes faster because of warming, then you can easily see that the biomass in general will start to shrink back. In terms of the terrestrial biosphere sink, there is a serious possibility that the sink will saturate sometimes possibly this century, depending on how much it reacts to temperature and what level the growth doesn't exist anymore. So saturation and even an outgas of CO2 from the terrestrial biosphere is well possible. In the ocean, we can't say that the sinks will saturate, although it's possible that they level off to some extent, like what we see in the Southern Ocean at the moment for the past 20 decades. The sink of the ocean is much more resistant. It will last for a long time, and it will take up the emissions. The ocean is more the rate at which things happen. And so if the sinks respond to climate change in a very serious way, the CO2 will then not be taken up by the sinks. It will stay in the atmosphere and cause more warming by somewhere between, well, the estimates now are 0.1 to 1.5 degree more warming by this century. In the ocean as a whole, it will not saturate, but some regions, for instance, the Southern Ocean hasn't increased at all, so it hasn't saturated, but it's leveled off for 25 years. And the North Atlantic CO2 sink, which is very intense because of a lot of biological activity, appears to be now reducing and possibly, yes, saturating over some period. We don't know if that will recover or not. We don't really know the causes of this at the moment. On land, we can talk about real saturation because the CO2 sink on land could stop if the fertilization by CO2 stops, and also it could even reverse and start putting its carbon to the atmosphere. So that's much stronger immediate impact. If the two sinks become weaker because of climate change, then the result will be that less CO2 will be absorbed by these two sinks, thus it will stay in the atmosphere and cause more warming. And the estimates at the moment is 0.1 to 1 and up to 1.5 degree more warming by the end of this century.